Welcome to a lesson with Dr. Powell. Let's take a look at an optimization problem in calculus. Suppose that we have some material that we want to cut out a cut in order to make a box like this. And suppose it's going to be an open box with an open top. Okay, so we'd like to know what value of x we should have in order to maximize the volume. In this particular situation, let's suppose, for instance, that this piece of material is, suppose it's, let's see, let's do like 4 by 8. So let's suppose that this is 4 and this is 8. How would we do this? Okay, so we want to maximize something, so we should come up with a formula for what we want to maximize. In this case, we want to maximize volume. And we want it to depend on x. So the output of the function should be volume, and the input should be x, the formula we want to take a derivative of to find a maximum value. So we think v volume, right? And maybe we'll just write down this, just a formula for volume, and then make sure it's in terms of x in a minute. How do you find volume? Well, if we think about this, this is x up, L, and W, so it's x times L times W. Right there, so x times L times W. Now L, what is L? L is going to be 8 minus 2x. What's W going to be? It's going to be 4 minus 2x. Okay. We have our formula for volume, and that's what we want to find a derivative of. In fact, we could write this in function notation. All right, so then in order to find it, we need to find the derivative of volume. V prime of x is equal to, so we could take this and we could multiply it out. I guess we could do product rule 1 by 1 and then work with that. But really, in the end, I think the easiest thing here in this particular case is just multiplying it out, because this is just a binomial times a binomial. That's fairly simple. And then just times x in the end. So let's just do that before we take a derivative. So maybe what I'll do is, let's see, I'll keep the x on the outside for a minute. Let's just multiply this through. 8 times 4, 32. Then we have 8 times negative 2x. So that's negative 16x, and then negative 2x and 4 is negative 8x. So that would be negative 24x. Yeah, just double check. Negative 16, negative 8. Yeah, okay. And negative 2x and negative 2x gives you positive 4x squared. Okay, and I'll multiply that and rearrange it. So that looks like 4x cubed minus 24x squared plus 32x. Take a derivative of that, we end up getting 12x squared minus 48x plus 32. Okay, now it looks like we can factor out a 4 out of everything. So, right, and we will be left with a 3x squared minus 12x, and then plus 8. Okay, so 4 times that, so that's the derivative. You just know where that's going to be equal to 0. Is that factorable? You'd have to kind of work through that one, thinking through different combinations that would actually work or add up to 12 from 8 and 3. So let's see, 4. And I don't exactly see it immediately, but let's see. and maybe there's not. So we can use my technique that I have for solving quadratics quickly. 3, -12, so you can look at my video up on that if you'd like. So, or using, it's equivalent to the quadratic formula, but it works nicely. I'll explain it as I go a little bit, but look at that other video here that I have on that for an alternative, quick alternative to the quadratic formula. So here, little synthetic division diagram. I don't know what's here right now, but I just drop the 3. I drop half of this, so -6. And then what I do is I take this divided by that, change the sign. So -6 divided by 3 is -2, change the sign to +2. Take this 2 times -6 is -12, put it here. Then add down, so would give me -4. Okay, so basically what I have is you have this guy, so x is equal to 2 plus or minus the square root of, so the way we got this 2 was like this divided by this, change the sign. So what you get in the square root actually comes from going to the next spot. This divided by, so this divided by the 3, change the sign. So -4 divided by 3, change sign. So square root of 4/3. Aha. So now we don't want, let's see, so we get 2 options, and realize that actually, so we get 2 plus square root of 4/3, and one of these will give this to us. And let's think about this for a minute. The derivative is a parabola, right? So as n behavior up, and it's going to be crossing 2 points here and here, and because we have them right here, and it's up, n behavior up, so it's going to go like this and this. And if you think, okay, the derivative is positive, so the function goes up, then it goes down, and then it goes up. Okay, so like positive derivative, negative derivative, positive derivative. So up, down, decreasing, then increasing as we go. So if you think about it, is if it's too big, let's see, 2 plus the square root of 4/3. So that's going to be like, that's bigger than 3. And if you think about it, ooh, yeah, if x is like bigger, see what happens if x gets too big? If x gets too big here and here, that's going to like, this is only 4 long, right? If x is like getting up to 3 and 3, so 2 plus square root of 4/3 is actually not a good place to be, it looks like, in our situation. So we're really going to be looking at the one we want. In fact, looking at this is like increase. This is a max anyway at that point. So looking at x being 2 minus, so x should be equal to 2 minus root of 4/3, and that should give us a maximum. So that should give us the maximum volume in our particular situation, because realize as x is getting taller, you're also getting skinnier. If x gets too big after a point, there's some skinniness involved here, but that's counteracting here as well. So you have all these different factors coming together. But in this particular example, x is equal to 2 minus square root of 4/3 will actually give you the maximum volume. Thanks for watching.